G'day guys, just Benno again. Just going to talk about the next stage of our sustainable yield modelling. So the last stage we spoke about creating the CPUE model, which we produced two numbers, the A function and the B function, which were the intercept and the slope of a line or vice versa, which we now input into our sustainable yield model to create what we might call our maximum sustainable yield, or short term MSY. And because we're looking at sustainable yield, we're measuring the amount of weight that we take, or volume, some people call it, against the amount of effort used to take X amount of fish. So effort might be, let's just say, given nominal numbers, 1, 2, 3, 4, 5, and that might represent the amount of boats that are in the fishery, and this may be, like 1,500 tonnes, 200 tonnes or something like that, just as a quick estimate. So what happens when we access the fishery and we start fishing it, the more pressure we put on it, the higher our catches become. So we end up with this line that starts to taper off after a period of time, to the point where, oh hang on a tick, put too many boats in the fishery, they're all fishing with equal amount of pressure, hopefully, because we regulated it. If we keep putting that pressure on regardless of how much effort is being used, in terms of how much net or how much line or whatever it might be, the more the effort increases, eventually we get to the point where we collapse the fishery and it's no longer viable for us. So what we're after is this point here, right? And we can basically draw a straight line down from there to there to say, hey, roughly 4 boats in that fishery is enough, and it's going to produce us 1,500 tonnes. Right, that's what we're after. After that point, if we brought in 6 boats or 7 boats or whatever it might be, we start to say, hey, draw lines up, and oh, hang on a tick. At that point there, we're only producing, say, 500 tonnes. So we've got to be careful about how we manage our fishery, because if we get it wrong, we may just collapse it. So we look at MSY as a way to manage a fishery based on what we deem the sustainable point, which is at the top of the curve before everything starts to collapse. So what we're going to do now is to get you to open up the work that you should have saved last time round, alright, and we're going to talk a little bit more about it. So hopefully you've saved the data from the last CPUE tutorial, and we should note at this point that as CPUE increases, we should hope that catch increases with it as well, to the point where CPUE should be as high as possible while maintaining this level of sustainability. We don't want to have CPUE creep away. We don't want to have our catch increase while let's just say catch is high up here. Alright, but the level of effort has not comparatively changed. Let's just say we're down at 3. So our level of effort is decreased while our catch is increased. That could indicate something like, call it effort creep. It could also mean that the fishery is actually really active and actually doing its job and we haven't exploited it enough. But we've got to be really conscious that effort creep isn't clouding our judgment based on the fact that, hey, we're catching heaps and our effort's really low now. Let's open it up for more boats. Let's put more net on. Just got to be really careful with that, because it could be effort creep that's actually doing that. So let's move on from here. Just give us a new sheet here for a second. Alright. So what we're going to end up with now is we need to write another additional formula into Microsoft Excel in Microsoft Excel formula layout, so equals F2 with cell references pretty much. So let's look at the actual formula itself at the moment. So the formula, the way it was written by scientists, it equals y equals AF times by BF to the power of 2. Alright, so this function here and this function here come from the slope calculation and the intercept, alright, which we calculated back out in CPU, and we'll talk about that in a second. And this F function here, as it's written in both of these, is our nominal amount of effort that we're going to allocate to this fishery, which we break up evenly. So we might just say for the fishery we're talking about orange roughy, we might start with 4 toes or something like that, and then increase it all the way up to 1,000 toes. Right, we're talking about this New Zealand fishery. So 4 toes to 1,000 toes, and that 1,000 toes fishery is collapsed. Alright, so what we're going to do is take this formula here, and we're going to write it out in Microsoft Excel, and then we're going to follow through to calculate the curve as I displayed back in this sheet here. So we'll have a curve that represents something that looks similar to that without a little scribble on it, and then we should be able to interpret from that roughly where, or not roughly, approximately I should say is probably a better word, where our most sustainable point is. So I've just opened up my sheet, right, from that I saved from the last tutorial, and what I'm actually going to do is I'm going to work on an additional sheet. So I'm just going to go down here to the bottom left hand corner. I'm going to rename sheet 1 to CPUE. I'm going to call a new sheet and I'm going to rename that MSY. Alright, and then I'm going to take these two bits of data here. I'm going to take them over with me to the next sheet. So just left click and drag around those, copy them, and then place them at the top. Normally I would just go paste special or paste values or something like that, which I'm happy to just paste values for now. Alright, so now what we need to do is to fill out effort and yield. We've got 2 new columns that we're going to use. Alright, and this effort here is still going to be toes. Alright, and because the data we used back on this CPUE sheet was measured out in tonnes, we're going to keep it in tonnes simply by putting the measurement in here as tonnes at the top, or something similar, as long as it looks close and you've got an identification around it. Alright, and if we look back at our data set very quickly, we can see that probably the minimum amount of toes was around about 200. Let's just start at 200. Alright, and the maximum amount of toes these fisheries have ever gone to looks around about the 4,400. So what I really want to do is I want to force the chart to collapse. So we're going to start at, let's just start at 0, alright, and then bring it up to 200, 400, so on and so forth. Alright, once we've got a logical formula in there, we should be able to go 0, 200, 400, highlight over all of them and then fill down. Alright, until we reach, I'm going to go 5,000. Alright, so we've just put these theoretical numbers in at the moment to say, hey, if I'm at this level of effort, the formula is going to go into the yield column based on these 2 numbers up here, and for a level of effort of 0 we should get a number that equals 0. So in the yield column we're going to go equals, alright, and then we're going to put in a bracket, alright, because we need to use brackets, and I might refer you to a BIMDAS tutorial, or just to maybe even do a Google search on the internet for looking at what BIMDAS is, or BINDAS, or BODMAS. It's got a heap of different names, and it's really what we call the order of operations in relation to what we want to force Microsoft Excel to calculate first before it moves to the next set of numbers, and the brackets force Microsoft Excel to calculate stuff first. So our formula as written up on the whiteboard before was equals AF times BF2 or something like that. Alright, I'm actually just going to copy that out of that formula and place it up the top, just so that you've got a reference of it. Why didn't
Maybe let me do that. Paste. Let's just go paste text. That's not letting me do that. Give me 2 seconds. Okay, if you have trouble moving things around and text things pop up, it might be because I had an equal sign in there that was stopping that from being just text. So if I put an equal sign in there now, it's going to go value or name. Alright, so if you get that stuff, maybe just go have a look and see if you've got an equal sign in there. So it'd be good if you just write that formula up there just so that you know what you're actually calculating, and I'll talk you through it from here now in terms of the formulas. Alright, so back down here, press equals, put a bracket around it. Right, then we're going to say, hey, we need to use the A, which is this value here. Alright, and then multiply it, even though that this doesn't have a multiply sign in here, we're assuming, scientifically speaking, that once we've got stuff inside brackets, it's multiplied. So you need to put the multiply sign in for me. So multiplied by the number of effort that is next to it. Alright, so it's C3 times B7, bracket, and I've actually screwed this up here. Give me 2 seconds, I need to change this formula here. It's not a multiply in there, it's actually a plus. That's my brain fade. Alright, and then we're going to go through, do shift on the keyboard, next number next to backspace normally, and then we're going to put a bracket around the next set of data that we're going to calculate, which is the B number multiplied by the F number, but we need to make sure that that effort number this time is multiplied, or it's a squared number. So we need to put another set of brackets around that. Shift 6 on the keyboard 2. Alright, that basically says B7 times B7. That's what that little number in the middle is there. It's just the square function on Microsoft Excel. So to make sure that that's calculated by itself, we put that in its own set of brackets, and then we close that whole formula so that this section is calculated. So this is all calculated, and then, sorry, this is all calculated first, this is calculated and then applied to that, and then they're added together to give us our answer. Alright, so once that's calculated, we can press enter. Alright, and our answer, as we should know, is 0 tons. So just go through and do that for me. I'm just going to press pause, go through, do that for me, and when we come back we'll talk about filling down and so on and so forth. Okay, so hopefully that wasn't too much of a nightmare for you, and if you did have issues, hopefully you brought them up with me so that we can talk about it over the phone or via the email. But I'm about to show you the problem with what we've done. So in the last CPUE session I said to you, let's just fill down. And if you've jumped ahead of me, you probably tried to fill down and noticed, hey, hang on a tick, this doesn't look right, I've got values all over the place. Alright, what that logical fill down does is it takes, I'll just get rid of all that stuff there for now. Control Z gets you back to where you need to be. If I fill down, what this formula is going to do is it's going to take the purple reference cell and the blue reference cell, and it's going to shift them down to, so C2 is going to shift down to C3, and C3 is going to shift down to C4. So on and so forth. It's going to keep filling down because we haven't given it a way to lock away the numbers that we need to refer to as what we would call our reference values. Alright, so to lock those values, so in the blue cell here, cell C3, alright, if we put a $sign at the start and a $sign between the 3 and the C, and the same with the C2, alright, it's going to lock the column and the row. Alright, so putting a $, before the C will lock the column. Alright, but then we would, if we move column for instance, we would, the column would still shift with it. So to lock the row and the column together, we put a $sign before the column and a $sign before the row. And then theoretically, if I come off and enter it this time, when we fill down, alright, so over to here, change our cross to a just a black 4 cross. Alright, we fill down, alright, we get something that shouldn't be doing what it's doing. Alright, and it means I've screwed up my formula. So just illustrating what's happened, we've started here. By the time we hit 5,000, we should have been tipping over the limit by miles, but all it's doing is increasing which to me says that I have a value wrong in here somewhere, and I'll find it and I'll get right back to you. Wow. It looks to me that there wasn't really an error in the formula or anything. So I've gone through and I've locked everything up, and this formula is correct. But I've gone through and I've calculated it all, and it does. I don't collapse the fishery until 13,400 toes, which is absolutely insane from my looking at the moment. But maybe when we continue through, we can find out where the actual tipping point might be, and then later on the dean would sort of make a decision, your management group, or you might speak with the research scientist to find out what's going on. And it may directly relate back to here. Remember how I was saying about the reliability of this data over here, this R-squared value being only really 5% accurate? It may be the reliability of the data in question might mean that we have to operate the fishery under the precautionary approach, where we set some constrained figures on the target and limit reference points based on the fact that the data at the moment is sort of indicating that we could potentially be fishing a lot harder, but who knows. So for now, just go through the process, write out your formula up here, so $C, $3, yada yada yada, and the quick way of doing that is to basically go in, put your equal sign in, put your reference values in, so multiplied bracket, making errors here all over the place. Go to your A value, multiplied by your multiplied by your effort, close the bracket, put the plus sign in, open the bracket, go back up to your B value, multiply that by an open bracket, effort to the power of 2, close 2 brackets to finalise the formula, and press enter, and then from there we can fill down, we can go back in and say, hey, if I need to fill down, put dollar signs to lock your cells in place so that they don't move. They'll always be referred to in that formula context. Alright, and then when we fill down, we should have everything fill out nicely without any values or names or dollar signs or hashtags or anything in there. And then you can just fill down it until, I encourage everybody to fish it till it collapses, or not fish it, but theoretically fish it till it collapses, because it gives you the best representation on your chart. So from now, get through, do that for me, and then we'll go on to the next step. So let's, from here, look at our data, and we've got a lot of data points, which means that our chart is likely to look quite neat, and it's going to be a little bit more precise. Sometimes people will go, oh, just go up in the effort levels of 1,000, or just got to look at it, separate it out, make it, quite a number of data points, because it's going to give your data a lot better chance of being precise when it comes out the other end. So let's go up to insert. We're going to insert another scatter chart. Alright, and we're going to select our data and our add. So our Y range is the yield. Yield goes up the left hand side. We're going to scroll all the way down, lift, click and drag over everything. Our X values is our effort, or i.e. our number of toes, and you can already see the chart taking form. Alright, click OK, OK, scroll back up to our chart, and we can see now that we've got this nice chart that we can probably make a little bit bigger if we need to, so we can see the approximate point where the chart crosses over here. So we know that when we collapsed it over here at the bottom of our data set, we're around about 13,300, somewhere between these two levels of effort, in this case toes. And then what we need to do now is to apply another formula to find out really finitely what that point might be for our maximum sustainable yield. So just go through, put the chart together for me. I'll pause the video just for a second so that you guys can go through and recreate the chart. So make sure it's a scatter chart, go through and make sure that yield is on your y-axis, your effort is on your x-axis, and just make sure it looks something like that. Alright, so hopefully you've got the chart. Now what we want to do is to create two data assessments. Now we want to take MSY, which is essentially, I'm just going to put next to it tons, because that's what we're chasing. So it's a yield, so it needs to be written out in tons. And we're going to have FMSY, alright, which is our effort required to take MSY. So I'm just going to put effort in there so that you sort of know that one is a level of effort and the other one is a level of catch, pretty much. Right, both of these formulas, I'm going to write the formulas in without the formula calculation, i.e. the equal sign. So it's going to equal, the formula that the scientists tell us is minus a to the power of 2 divided by 4 times b. Alright, and the other formula, sorry, I should have taken the equal sign out of there. Alright, it's not letting me do it. I'm going to have to put space in there so that it recognises it. So space minus a divided by 2 times b is going to tell us the sustainable level of effort. So we can look at it and say, hey, let's set our level of effort at X to achieve how many kilograms of fish is required to be sustainable. So to do that, let's just go into the column next to it. So I encourage you to put these formulas in so that you know what the reference formulas are, and then next to it just write the formula in as we should for writing out in Excel format, realistically. So we're going to go, this needs to be a minus in front of the bracket, by the way, minus a to the power of 2, so where we're tidying, bracket, divided by open bracket, 4 times b. Alright, and once we press the enter key, okay, what's it saying? Oh, sorry, I've been a bit of a nitwit up here. I forgot to put the to the power of number in there. Alright, so at the moment it's basically saying that our sustainable level of, I'll just trim it up a little bit, put a comma in there so we know where we're looking at. Basically they're saying our sustainable level of catch is 8,581 tonne from that fishery based on the data. Alright, and to calculate out what our level of effort required to take that catch should be, it's the same formula, relatively the same formula I should say. And we just go back through and repeat it, but with this set of numbers here. Alright, so this formula is what we call the surplus yield model, and it's all derived from, well, this formula here I should say is the surplus yield model, parabolic yield equation, and we use it for the sustainable yield modelling. And now I've gone off on a tangent and I need to get rid of it. I mean, making mistakes everywhere. So, right, back on track, equals a, oops, equals minus bracket a to the power of, no, it's not to the power of at all, just that, divided by bracket 2 times b, oops, sorry, 2 times b, and we may even be able to just get this bracket out of here because there's not too much else going on. I'll just check that to make sure, just by putting a bracket around it. Don't think the brackets in that situation make any difference whatsoever because we're not applying another number to it, so it's the same. So simplification, take the brackets out, because all it is just putting a minus on that number. Alright, so at this point in time, if we come down to our effort and we run along our chart, right, we come along, we're coming around about halfway. Alright, we can see that, hey, it is around about the point at the top of the curve, which is exactly what we want. So at this point in time, I would go over to here to insert, and I would just insert a shape and make it a line, Alright, and I would come to roughly where I think it is. The better that we've got our precision, the better it is, I should say. Escape, sorry, made a mistake. Insert a shape, insert a line, come across the halfway, and if you hold the shift key down when you do this, it'll draw a straight line for you where you believe it might be. Alright, and at the moment it's not anywhere near where I think it should be. Alright, so we shifted across just to represent where we think it should be there. Alright, and at that point we can change the colour of the line just by changing the shape colour. Make it red because red and blue are easy complementary colours. And then I can do the same thing up here where I think my 8,581 tonne is, which is probably roughly where that line fits right now. So insert another line, come across to here, shift, drag it across. And these are only in there just to sort of indicate as nominal indicators realistically as to where the two lines meet, and just to visually represent to people where we think our sustainable trigger point should be set at. So realistically what we're after at the moment is our target reference point would be this point up here, or a TRP. So target reference point for this fishery, based on the information that we currently have, that our target reference point is around about 8,581 tonne, and to achieve that we're going to use 6,681 toes to produce that amount of fish. Now, as I said, the data looks to be unreliable. It seems quite high for me. I would be going off to my team, speaking to my supervisors or whoever it might be, obviously the researchers involved in it, and questioning that at this point. For the furthering of this, for the further education of you guys, we're going to keep continuing with this model, but I would just be indicating that, hey, it looks a little bit high in terms of the catch and the effort that we put into it, based on the original numbers that we already see a decline in our catch, probably at around about 1,200 to 1,200 toes, it looks like. Where's our CPUE? Sort of hovers around about that 1,200 mark anyway. So I'm going to leave it there for now, and I'll develop another, or get you to have a look at the CPUE in relation to MSY in the next scenario that we have, and we'll talk about it from there.